Good evening, students. I assume most of you have flown in a plane before, but as you're in that metal tube hurtling through the air thousands of feet above the ground, have you ever wondered how the plane is actually flying? Have you ever wondered why you're not plummeting to the ground and are instead gracefully moving from one location to another? Well, I'll explain that to you. I will be explaining the most basic and fundamental concepts of aerodynamics, how the plane is actually flying, and how flight changes once you reach supersonic speeds. Starting with the most fundamental concepts of aerodynamics. According to NASA, the most simple way to think of aerodynamics is as a logical extension of the laws of motion. The principle of inertia, the idea of force being the change in momentum of an object over time, and the idea of equal and opposite reactions. You take those three principles, you stretch them out, you adapt them for the situation a little bit. That's aerodynamics for you. However, according to NASA, aerodynamics is also an expansion of fluid dynamics. This is because air itself is a fluid, and so the principles of fluid dynamics still apply to an object moving through the air. The most important of these principles is air resistance, otherwise referred to as drag, which is the idea that as an object is pushing through the air is pushing back against that object, equal and opposite, in accordance with the three laws of motion. Because air is a fluid, however, it engulfs and surrounds the object moving through it, which causes resistance in multiple locations. And as these pressure changes and forces acting on the object are different in different locations, that results in a net force that causes the plane to move, in accord with the three laws of motion. The most important things to remember with aerodynamics are lift and drag. Lift is the force perpendicular to a plane's motion that is pushing the plane upwards. And you'll hear a lot of big and complicated terminology about aerodynamics. It all relates back to defining lift. And the other key component is drag, which, as I explained earlier, is directly inverse to a plane's direction and is scattered because the fluid providing the drag is scattered along the plane, unevenly distributed, which causes an uneven net force that causes the plane to either rise, fall, go forward, go backwards, ideally go forwards and upwards. Understanding these basic concepts, you'll understand how the plane can fly. The plane flies because of lift. Lift is provided by the wings. And an important thing to remember is that it's the shape of the wing which provides the lift, not the distance of it. There's a myth that wind travels at different speeds over the wings and they meet up at the same time, which causes the lift. That's not true. Wind does travel at different speeds over the wings, but they don't meet up. They instead cause pressure differences on opposite sides of the wings, which causes thrust and lift to occur. And according to Nordian, a flight training company, the angle of attack, which is to say the angle at which the wing is facing, is also extremely important. And depending on the angle, you can even stall out. When you can balance lift and drag against each other in a formula known as the lift-drag ratio, which the ideal goal is to get that ratio as high as possible without stalling out, according to Nordian. And the rules get a bit iffy when you're talking about supersonic flight, though, because supersonic flight is once you reach above Mach 1, otherwise known as the local speed of sound, which causes a lot of problems, such as force differences and just a bunch of unpleasantness along the structure of the plane. Most people devise supersonic flight into 3 distinct regiments: subsonic, transonic, and supersonic. Some, such as the Spartan College of Aeronautics and Technology, include hypersonic as being greater than Mach 5, but most people don't really use that, and you don't really need to use hypersonic, in all honesty. So you can just focus on the main 3 regiments. But the main principle to understand is that as speed increases from subsonic to transonic to supersonic, you will have shock waves traveling over the plane, over the wings, which causes a lot of problems. You don't want these shock waves, but as you go faster, the air will exert more force and more drag onto the plane, which will cause more shock waves to occur, which is known as transonic drag rise, which is a sharp increase when approaching Mach 1. That drag rise causes a lot of problems on ill-suited planes. And increasing the shock waves also increases the heat, which again, more structural problems. The best way to fix this is with just getting rid of standard wing design and replacing it with delta wings and BWB wing design. The blended wing body, which is where you essentially turn the whole plane into one giant wing. A 2003 study by the Boeing company showed that BWB wings, plane shapes, is quite viable for high subsonic flight. And Jet Zero, Northrop Grumman, 2 companies developing planes, agree with this. And they are currently developing a plane called the Z5, which is a BWB shape and will allegedly, according to them, greatly reduce fuel burn by almost half, by greatly reducing drag and massively increasing structural stability. So the shock waves and the heat changes won't be as much of an issue. The Northrop Grumman has developed the B-2 Spirit, which is the same basic shape as the Z5 is going to be. And the Air Force, which operates the B-2 Spirit, claims that it can travel up to 50,000 feet and reach high subsonic with minimal issues. It's quite a good plane because of the BWB design. The other design is the delta wing, which causes the shock waves to almost drip off of the plane rather than directly hurting the plane. Very good, very useful. And in conclusion, air travel is still developing every day, even as we speak. And the principles of aerodynamics are being bent and pushed all the time, especially in the fields of supersonic flight. And who knows what the future will bring. The Z5 is supposed to come out in just a few years, so we'll see how a high subsonic passenger plane will turn out. Thank you very much for attending this presentation. And thank you very much for listening to me present about the most basic principles of aerodynamics, how those basic principles can create flight in a plane, and how to use those principles to deal with the changing situations of supersonic flight. Thank you.